All other tropical storms must bow before El Nino. Yo soy El Nino. For those of you who don't habla español, El Nino is Spanish for the Nino.
The notion that a drought in Indonesia or the Philippines could be caused by the same conditions that produce torrential rains in the United States, Peru, and Chile might appear to the casual observer to defy logic. But in fact, that's exactly what can happen during the extraordinary chain of events known as El Nino.
El Nino is the appearance from time to time of warm water in the central and eastern Pacific Ocean. Normally there's a pool of warm water in the western Pacific, and that's because of the way the earth turns and the winds blow. Water piles up in the western part of the basin. The sea level along Indonesia and the Philippines is higher by 60, 50 centimeters than it is off the coast of Peru. So what happens is the winds keep blowing, the water piles up, it heats up in the western part of the Pacific, but then once in a while, could be every 2 years apart, could be 10 years apart, that wind weakens, and that warm water that's piled up sloshes back towards the central and eastern Pacific. Where the warm water is where you get your evaporative processes, evaporation, and clouds that produce rainfall.
Now that has an effect locally, as you can imagine. Ordinarily, with all those rain clouds over Indonesia, there's a lot of rain in that region. There's rain over Australia. It's fairly dry in the east. During an El Nino, when you've got all this convective precipitation over the east, it can rain a lot in that region. You can have flooding in Peru. Conversely, you have drought over Indonesia and Australia. It can also have effects pretty far away, and the reason that happens is the atmosphere can support these wave-like motions. It's just like dropping a pebble in a stream. Although the pebble is at one little place, you know, the ripples can go very far away. So those ripples can extend, say, over North America and change how the weather patterns over North America are.
How much of what you're telling us today about El Nino being renewed?
In recent years, El Nino events have become the focus of intense scrutiny and discussion, not only among scientists, but within the ranks of the media and the general public as well. In fact, however, the conditions that give rise to these events have been observed for well over a century.
El Nino was named by the Peruvians, actually the first time we've been able to find it in print, looking through Peruvian newspapers, etc., has been 1891. 1892, 1894, 1895. It's the 1890s, early 1890s when it took hold. And it is because during the Christmas season, that winter, December, January, February, the winds would become weaker, just seasonally weaker. And as a result, fish would disappear. The fishermen would fix their boats and their nets and that kind of, they would lay off of fishing. And because it came around Christmas time, they called it El Nino with capital E and a capital N, which means the Christ child.
The original term El Nino was a much more limited term that had to do with the flow along the coast of Peru and Chile along South America. Now we know that this is not just a local event. It's a much larger scale event. It certainly encompasses the whole equatorial Pacific, maybe has some ramifications in the Indian and Atlantic Ocean as well.
Although scientists understand a great deal more about El Nino events than they once did, there are still many unanswered questions. One of the most basic concerns the precise mechanism that triggers an El Nino.
It appears to begin as an atmospheric event, which quickly transforms into an oceanic event as the water masses in the equatorial Pacific redistribute themselves in response to changes in the wind. This redistribution of mass results in flows, which is what we call currents. But the redistribution of mass associated with that is also a redistribution of heat. And as the heat is moved around, this then feeds back into the atmosphere and over quite long distances.